Our aim is to try to meet the environmental impact by reducing the emissions from the engines and to improve the fuel consumption of engines to reduce the CO2 global warming effect. Our work here starts from the basic theory through the experiments to the development of engines, and with working with companies like Ricardo.
The key drivers for automotive research are to move towards much lower carbon vehicles and lower carbon emissions in general to meet with Kyoto targets and hopefully future targets. In Europe, for instance, we have a target to meet a level of 130 grams per kilometre for fleet average vehicle emissions by 2015 and potentially to 95 grams per kilometre by 2020. To give an indication, 95 grams per kilometre is equivalent to a vehicle doing about 70 miles to the gallon.
We use lasers, first of all, to look inside, virtually look inside the engine, to understand the fundamentals of each of these processes individually: air motion, sprays, mixture preparation, combustion performance, and then the emissions themselves. The ultimate goal is basically to build a computer model of the engine, so it's like a virtual engine, so we could use that computer model to optimize the design of these engines and also to speed up the development process. Experimental work takes time, computer work is a lot faster. To do that, we have to produce models, and my colleague, Professor Sergei Sajin, leads the modeling group that develop these models that we put in the computers. But these models need empirical assumptions that we need to make to solve the equations that describe these fundamental processes, and we need to validate these assumptions using the experimental data that we're doing here, and hence the fundamental work using the lasers. This is an example of the air motion inside the cylinder using the laser technique we call PIV, particle-induced velocimetry. And now it's an example of the sprays using, again, lasers to look at the spray performance, spray characteristics inside the engine. And that shows the mixture preparation, mixing the air and the fuel together to look at how they mix together inside the engine. Then the firing. This is how the diesel sprays ignite inside the engine. That's actually looking at the combustion process itself. Now, having done all that, we then move on to test basically our theory to see whether that works or not. The next stage is we go from the research lab, and this is where our collaboration with Ricardo is invaluable, go from the test lab to actually producing a pre-production engine that Ricardo can test in their own laboratories to try to validate the whole process at the end.
We're working with the University of Brighton because over a period of 18 years we've developed a very successful collaboration looking at fundamental research where the university has some key skills in optical diagnostics. We have some key skills in combustion characteristics, and when we've joined those together, we've developed a very successful partnership on a very leading edge facility to develop an understanding of what's going on inside combustion engines and to work out how we might improve that, reduce their polluting emissions and also reduce the CO2. One of the projects we're working with the university on is called the 2-4 car project. This is a small gasoline engine which most of the time operates as a 4-stroke engine, a conventional engine, and then when we need more power and more torque, we convert that into a 2-stroke engine where we fire every revolution instead of every other revolution. This produces instantaneously a very high torque and gives us very good drivability. So in effect, we can replace maybe a 4.5 litre engine with a 2 litre engine that delivers the same torque, the same drivability, but much improved fuel consumption. The impact for this is primarily to support the UK industry, which has very good reputation in premium vehicles, which have large engines. And we need to improve the fuel efficiency of our premium vehicles as much as we do our conventional mainstream vehicles, which are sold in higher quantities.
And that's the impact of the work, as we go from the theory, the equations, to lasers to look at fundamentals of the processes, to thermodynamic engines to test our models, to then finally produce the engine.